So this is a DC motor question. Let's go and see that question and read it. Okay, it's a 7.5 horsepower. So again, this is the rated value of the machine, 120 volt. This is the input voltage. Remember, this is a DC motor. DC motor means its input is actually electrical and its output is mechanical. A series DC motor. So here it means that the field winding and the armature are connected in series. And we are given the value of the armature and the field. So if I want to draw this here, so we have R field, R A armature, and then I will have EC, and then I will have my VT, or let me call this as EA. Okay, and here the current is an input actually, and I will call this as IL. So that is the model of my motor because they are in series. Okay. Then here we are given the value of the armature. The armature is actually 0.2. The field is 0.16 ohm. Okay. And at full load, the current input, so at full load, your IL, because we have only one current here. In series motor, we just have one current, is equal to 58 amps. This is your current. And the rated speed is 1050 when you are supplying the maximum load. Okay, you are supplying this, you are getting this speed. Now we are giving here the magnetization curve at the no load speed here, okay, at 1200 rpm. Now, what is the efficiency of the motor at full load? Okay, so when we want to find the efficiency, as always is equal to P out over P in. Now, we need to find at the rated value, so we will use, this is your rated value. So your P out rated value, and this is the condition at which you want to find the efficiency, is equal to 7.5 times 746, which is equal to 5595 watt. So this is your P out. Your PN, remember this is a motor, so your PN is electrical. So we know VT, we know IL, okay, so it is 120 times the 58 amp, and this is equal to 6960 watt. From this, efficiency is equal to P out over Pn, which is 5595 divided by 6960 times 100, and this will equal to 80.4%. Very straightforward. Okay, now what is the speed of the motor if it is operating at an armature current equal to 35 amps? And that's a question that we need to spend some time to be able to solve. Okay, so at this condition, we have the speed 1050. At that condition, we want to find what is the speed. Okay, so there is a typical way how we handle this question. We find EA2, EA1, take the ratio, and then try to figure it out. Okay, so your EA2, this is simple KVL. So this is the voltage at the second condition when the current is basically equal to 35 amps, equal to the voltage, which is doesn't change, it stays the same in both cases, minus 35 times the summation of these two, 0.2 plus 0.16, and this will give me 107.4 volt. EA1 will equal to 120. Now this is at the rated condition, so this is a 58 times 0.2 plus 0.16, and this will give me 99.1 volt. Now I have EA1 and EA2. Now I can relate them as we usually do. So basically, EA2 over EA1 is equal to K phi 2 omega 2 divided by K phi 1 omega 1. Now the K will be different. But now here we want to find something related to the phi 2 and phi 1. And now because we are working in a nonlinear region, basically, we cannot just simply assume it's linear. So I have to use the curve given at that condition. Now, the flux that you have here is basically related to this is the current here. Okay, this is the series field current, and it is related to the internal generated voltage at that conditions. So basically, we need to find what I will call is basically EA0 at the second condition, which is at the 35 amp, and this is divided by A0 at the first condition, which is the 58 amp. This is actually equal to phi 2 over phi 1, because phi 2 and phi 1 is coming from the currents, which basically is inducing the voltage. So I'm trying to find the relation or the ratio indirectly by finding EA0, 1, and 2. Now, how to find EA0 at 2, a second condition? This is the field current here is equal to 35 amps. You come here, this is your 35 amps. You go all the way up, and it looks to me in the middle somehow. I mean, again, here it is any value in between will be acceptable. So your EA02 will equal to 115 volt. Now we want to find AA0 at the first condition. Here your IF is equal to 58 amps. Okay, so here your EA01, now 58 is somewhere here. Okay, somewhere here. So it is equal to some voltage in between. So you can say it's around 135, 134 volt. Okay, now once this is established, then your EA2 over EA1 equal to, now instead of phi 2 over phi 1, this will be equal to EA02 over EA01 times, instead of omega 2 over omega 1, we'll use N2 over N1, because as you know, the omega and N, they are related by the same, by a constant, which is the same for omega 2 and omega 1. Now, what is left here is, or what we calculate is N2. So from this is the speed at the second condition. So N2 will equal to EA2 times EA01 divided by EA1, EA02 times N1. Now we have everything. Your N2 will equal to 104.41 times 134 divided by 99.1 times 107. No, I think this is EA02, which is 115 times 1050, and from this is equal to 130.26 RPM. This is the speed of your motor at the other current, which is the 35 amp. So I will just stop this.